everyone. I'm Ms.S.Poorni from the Department of Industrial Biotechnology. I'm working as an assistant professor and I'm going to handle the subject for bioprocess economics and plant design. And this is the third year paper, and the unit I'm going to cover in this topic is a first unit. The first topics are the process design, process development, process flow diagram, and equipment design and specifications. So, before getting into the topic, we must be aware what is the difference between the design and the process. So, whenever we are going to make a process, the process are said to be the flow of your input to the output. So, whatever the steps that has been required for converting from your input to the output in form of your product and or services. So, that is said to be the process that is in the each and every step that has to be taken care for process development or for the product improvement. And when you talk about the design, so how we are going to form a particular product in each and every step, that is said to be the designing of a particular process. So we must be aware that what is the process? The process represents the number of your inputs and outputs, are the steps that has been covered in case of your input to the output. When we talk about the design is said to be the how this process is being carried out. Okay, so the definition, the exact definition for the design is, it is defined as a process of originating and developing a plan for the products, service, and their particular process. And when we talk about the process, it is said to be any part of your organization that takes an input set of resources that is used to transform a final output as a product or in terms of services that has been needed. So the next one here, when you talk about the process design, how the process is being designed. So what are the steps that has been included or derived in this case of it will be seen. So when you talk about your process design, the designing of a process not only should be in, it should be developed in such a way for producing the product in a larger quantity. So how it has been done? It can be done by the conceptual work which has been prior to the building or expanding into the process for producing any product. So this process designing, it has two main activities. The first one is the process synthesis. The second one is the process analysis. So when we talk about the process synthesis, how we are going to manufacture a particular product or in terms of your services. So it represents each and every steps that it comprises of for the production of your product. Okay, so that is why we have said it is based on a selection and arrangement of a set of unit operation that is capable of producing the desired product at a cost and a quality. And when you talk about the process analysis, how this process is being synthesized, whether this process is needed to or it has to be commercialized for a human utilization. So those things that has to be done for your prior to form the formation of a particular product. So that is why it is defined as an evaluation and comparison of a different process synthesis solution. And when you talk about a process synthesis, it is defined as a selection and arrangement of a unit operation setups so that it can be able to produce a desired product at an acceptable cost and a quality. And whereas the process analysis defines an evaluation and comparison of different process synthesis solutions. So when you talk about while designing any product for a process through the any process, that product has to be designed, that has to be in an commercialized, that in an economical cost. So while designing a process for any product, the project also to be taken into consideration, that a project that or implementation of a plan for a particular product that has to be in an economical manner. So which requires a knowledge from a different scientific and engineering disciplines that carried out at various levels in a detailed manner. So the next one will move on to your how the new product is being carried out that is available in the market for our commercialization purposes with the various steps. So here when you talk about the new product, how it is being synthesized. So when the new product is being synthesized, we cannot produce a product without any collection of data. So it has to be done the feasibility survey. So that is how we are going to evaluate, how we are going to produce, or how we are whether this product is needed. That is an analysis and through the synthesis method. And next one, developmental stage. So when we talk about a developmental stage, what are the various developmental stages? It includes various whether this product is needed for our commercialization purpose and what are the budgets, everything that has to be taken into the consideration. And then before getting into the market entry of your third level, and this has to be tested on an animal if the product is of a consumable one. So here, if it has been tested in an animal in the lab animal test, laboratory animal test, then our animal house model, then if it has been given a peculiar characteristics or a good result of 100%, then it will be entered into the market for our commercialization as a commercial products. So the next one we'll see how this process is being developed. So here, what are the various steps that involves while the process is being developed in such a way while designing the process? So that's why we have a term called a overall developmental process. So the first one, the first step, first and foremost, is a literature review. So how we are doing the project, so whether this project is a genuine or novel or new idea, so those things can be done based on a collection of your materials, that is the review of a literature. Then whether this product is needed or it can be produced by with the help of your catalyst, that is a biocatalyst screening that has to be done. Then how this catalyst can be optimized, so whether the product can be speeded up by adding the catalyst so that it will be involved in the process of your product formation in a large quantity. Then we need to optimize whatever the media and the reaction conditions, which means that the media in the sense whatever the input or raw materials we are going to give, and whether the reaction is being carried out at an optimum temperature or a pressure and your oxygen level, everything that has to be considered prior starting the process designing for the product formation. Then once a product has been formed, we are going to derive the product which will be having both in your final thing as the form of your desired and an undesired product. So those selection of a downstream step also has to be taken into consideration how we are going to derive the particular product. Then we need to identify the process flow diagram. The process flow diagram is nothing but your how this process being carried out in each and every step and what is needed and whatever the things that is not needed, everything that has to be taken into consideration for your any process. Then we need to optimize the unit operation and how this process we are going to implement, and that has to be scaled up in a level of your lab. Then it will be taken to the technical, then it will be taken to the industrial lab. That is how it has been scaled up. So scaled up is nothing but we cannot do any process in a large quantity at an initial stage itself. So we have to do it in a laboratory scale. So we call it as a lab pilot scale. Then it will be taken to your industry. Then it has to be, once a product has been produced, it has to be optimized in the case of an unit operation through your downstream steps. Then it will be approval for the clinical trial. So once that is, which means that it has to be tested in a animal laboratory house so that it will be used for a approval for your clinical trials. Then if your product has given 100% result, then it will be taken as a process modeling and their assessment of your environmental issues that has to be taken care. So these are the various steps which we will be having for your any process development. Okay. So the next one, we'll see how these steps, what are the steps that has been involved in the process design. So first step is said to be the product definition. We have to taken care that the definition of product should be in a defined manner, whether the product is needed or not in this case. That has to be taken care. And we have to analyze whether this product is specifically needed for any analytical purpose, or then it will be for the availability in the market for our commercialization. So here The first and foremost definition steps in this is said to be your product definition. So we have to do a literature survey whether the product has been already existing or we are producing a new idea for a product formation. So what are the specifications, whether it has been needed, and then only it will be available in the market. So the first and foremost step in the process designing is a product definition. The next one is the selection of the synthetic technology. So when we talk about a synthetic technology, the synthetic technology, how the process is being carried out for the particular formation or a production. So that comes under a category of a selection of the synthetic technology. The third is the process flow diagram. So how the process is being carried out in each and every step. So what are the inputs, what are the outputs, how the input is taken to your reactor for a product formation, and how the output we are taking through the your DSP in the final stage, and how what are the steps, what are the techniques we are using, on how this is carrying out with the steps. That has to be detailed explanation to be given in a process flow diagram. The next one is a input. So here in this case, when you talk about the process flow diagram, it also includes your materials that has been needed for raw materials or input or a water input or your pressure or antifoam agent or cooling water jacket or your hot water this thing, everything that has to be taken into consideration while designing any process. So then it has to be taken care for your equipment and their utilities and also the labors. Okay, so the next fifth one is an assess the assumptions and uncertainty. So assess the assumptions and uncertainty or your whether the process is being carried out for a product formation. It needs any assumption, or if there is any uncertainty, we have to assess all those things. Like whether whenever we are getting a product, we will be not having only the desired product. We will be having along with the a desired product will be also having your undesired product, the cell biomass and your byproducts, everything that will be formed right along with the product. So here we have to avoid or assess all your uncertainties and those things that has to be taken care by processing the designing. Okay. So the next step is identifying the economic and the quality hotspots. So when we talk about identifying the economic and the quality hotspots, which means that how this process is being carried out, that has to be identified, and whether this process gives you any profitability by taking your large quantity of your raw materials. It should not give you a small amount of a desired product. So the profitability at any cost and their risk, that has to be also assessed. And finally, it has to be able to create your research and development agenda. That will be the steps in the case of a process designing. So the first foremost is your product definition, the selection of the synthetic technology, the process flow diagram creation, materials requirement, then assumptions and uncertainty, economic and quality hotspot identification, and then assess the profitability and the risk, and creating the R&D agenda. So the next one is what are the various stages in the designing process? Okay, so those are the steps. So that comprises of 8 number of steps. And here we are going to see what are the different stages of the design process. So the first step is said to be the feasibility survey. So whether whenever we are going to form a particular product using your novelty of a new idea, so whether that has to be done, whether this a product can be designed or possible to form a particular product to the process designing. So feasibility in the sense, it is said to be the possibility of any product, and whether that product is needed or your product has any specification value or any commercialization value for a marketing as a marketing product. Those things that has to be done in a feasibility survey. The next one is that design. So that is the designing of a process. So when we talk about the conceptual designing, we have 3 types of a design: preliminary design, definitive design, and a detailed design. So then once it has been taken to the next level, that is said to be the construction, and then finally it will be taken to the startup operation. So which means that the product definition that can be done through the feasibility survey, and the process flow diagram can be explained with the help of these various designs, and then it's a final construction of a product process, of a plan for a product formation, and then starting up of a operations for a product formation. The first step. So here we'll see in a detail about the step 1, that is a feasibility survey. So what do you mean by the feasibility survey here in the sense? In this feasibility survey, it is said to be the gathering of data for a quick estimation. So it's like a rough estimation that has to be done in the case of a whether the product has been produced already, or if it has been produced, from what source it has been produced. If it has been produced, what process at a temperature or a pressure it has been produced. So those things and all data collections has to be done in the case of a feasibility survey. Then whether what in the process being carried out, we have to, before process being carried out, we have to check whether the raw materials can be obtained from the supplier with the particular cost, with the specifications that has been needed. Then it is said to be, that's why we call this feasibility survey as a rough estimation of your gathering the data. The next one, whether the next one is said to be the whether the facilities or equipment are available for the product formation. How this survey can be done? This survey can be done through your Google or your encyclopedias or Wikipedias or your handbooks or reference books or any reports or journal references. Everything that can be done with the help of your survey requirement. So this helps for your feasibility survey. So then once a feasibility survey, whether this equipment, this process is needed only this equipment or only this reactor or only this safety properties, everything that has to be taken. So when we talk about your not only the paper part from your reference that has been used as a feasibility survey, it can also be used for the facilities that has been equipment needed, and whether the data has been corroded, and what are the requirements that has been needed if you're processing the product in a particular plant, and what are the chemical properties of those reactant product, and what are the byproducts it forms as an intermediate. And once the product has been formed, how we are going to patenting, and then how we are going to shipping those products for a commercialization into the market. So the second step. So what is second step? We all know that the second step is the design. So how this designing can be done? This designing can be done with the help of a process flow diagram. So here in this case of a process flow diagram, how the process is being developed, and this is can be done with the help of a 3 types of a design. So those design we call it as a conceptual designing. So how we are going to develop the process? We are going to collect all the data to increase the accuracy that has been from the quick estimation from the feasibility survey. So I said the first step is the feasibility survey. So here in this case, we are going to collect all the data, whichever it has been in the quick estimation from the feasibility survey, that has to be collected in such a way for any product formation. So it includes all your laboratory, and also in the case of a pilot scale, or also in the case of an industrial scale also. In here in this case, there should not be any missing data, that should not be there, so that it can be taken to the next level for the designing process. So and this data, which also includes your designing, which includes your materials and energy balance, and understanding the effect of a various process conditions and those data. So it is like your semi work data of a conceptual designing. So here it represents the flow definition, cost estimation, simulation, process flow diagram, line list, equipment list, and the safety environmental review, and the specification sheets, everything that has to be taken into our consideration from the quick survey of a feasibility survey for a quick estimation of our data. The step 3 is the process design. So as I said, the step 3 is the process designing, which includes your designing of a process which has been in the 3 types. So this can be done before getting into the topic. We'll see what are the process designing that has been applicable in the case of your things. So the first one is an equipment design, piping layout, plot plan, instrument book diagram, safety review. The same thing as in the case that those data that has been collected from the feasibility survey and that has been analyzed in the case of a conceptual design, that will be taken into a major consideration in the case of a step 3 of a process designing. And what are the various stages? So here in various stages, if we talk, there are 3 stages or 3 different designing process, right? So the first one is a preliminary, second one is a detail, and third one is a firm. So when we talk about your preliminary design, so what do you mean by the preliminary design? So here in this case of a preliminary design, it is said to be a rough design and a calculations kept at a minimum level. So there won't be of any calculation. We will be giving only the input and it will be of a rough designing that has to be done. And this preliminary design, which also includes your estimate and design based on an approximate method. It's not in a clear-cut method. It is said to be the approximate rough estimation. That's why we have said it is a rough designing of a data. And what are the tools it can be used to determine whether we need this development of a particular product is to be justified. That also has to be justified. So it is said to be a workable process for the production of your desired product. This includes a simplified flow diagram, which means that a simple form of a diagram that has to be represented, like a quick estimation of a collection of a data from the feasibility survey, which includes your raw material cost and specification of any process unit that we are utilizing for the product formation, and those laboratory requirements and the labor requirements, electricity, piping, valving, everything that has to be taken into the consideration. So here, the next one we'll see about what are the investment that we are going to give, and those things modified as a piloting reveals new information about the process, suggesting whether we need any change of your process has to be done for improving the product specification. So that also has to be analyzed. So once the development in the case of a preliminary design is finished, we are using those data into the preparing the technology for packaging with the detailed estimate designs or prepare. So the next part, and it also includes how we are going to proceed the process of a product that has been produced through the particular unit operation or a bioprocess or in any scale of an industry. It also includes your packages. Then how we are going to pack those materials for a transportation, how we are going to do this shipping, and how we are going to do the transportation in the case of through the land or air or water mode of a transport. That also has to be taken into consideration before getting into a topic. So here, manufacturing process, your materials engineer process, then temperature pressure ranges, what is the construction of a material, our reactor, the raw materials and the product specs, utilities, rates, plot size and plot plan, everything that has to be taken into a consideration. So the next one is a definitive or detailed design. So the next one is when we talk about a definitive, the name itself, it indicates there will be a defined form of or a detailed form of a data that has to be there. So it has to have a more details than your preliminary design. That is a quick estimate or a rough estimate that has been derived from a feasibility survey. So this includes your equipment and design specs and not only your PIDs. Okay. So here the transition from your preliminary to the detailed designs, that has to be tied up to the financial commitment to be proceeded. That is for a commercialization of any product. So this includes your detailed plot plans, your pipe layouts, your wire diagram, design specification for each component, cost for your equipments and the raw materials that has been based on a quoted price from the vendors or a dealers or a suppliers. So the fourth step is the construction. So once all the data that has been defined in the case of a definite detailed or definitive design that has been collected from your preliminary design, and then we have to construct all the things that taken into a consideration to construct the whole plan for the process development. through the particular process. Okay, so here in this case, the first it includes your site preparation, the vessel fabrication, that is a fabrication vessel in the sense how the materials is being used for a vessels for a reactor to be proceeded, and the erection of a facilities, their pipings, their loops, and their reviews, and their how the operator we are going to train those candidates. So whatever so each and every unit operation that will be needed in the case of your large scale industries, that as person has to be trained in such a way, he has to train in such a way that he has to cope up all the drawbacks that has to be done. So the step 5, what is the step 5? So when we talk about the step 5, it is said to be the startup operation. So when we talk about the startup operation, the process is going to start. So imagine the process is going to start how we have been designed in such a way for a product formation. So here we have to calibrate all the instruments before starting off the process, and your pressure operations of a loops, your reviews, startups, operations for your environmental monitoring. If you are making the wastewater to be entered into the environment, that everything has to be assessed before starting up of the operation. So all this data, how we can be stored in a database using your computers. So using of a computer simulation in the process designing. So all the data that we have been collected through the feasibility survey, or a preliminary design or a primary design or a detailed design, everything that has to be taken, each and every care that has to be taken, and those data that has to be saved in the case of a database. And those, if whenever it has been needed, it can be taken up so that the data can be optimized in such a way to be in an economical product designing. Okay. So the next topic we'll see about the process flow diagram. So when you talk about the process flow diagram, it can be represented as a PFD, which means that whatever the steps we are using to generate a product or developing a product with the help of a unit operation equipment. So when you talk about your bioprocess, the bioprocess is said to be your always a fermentation process being carried out in the type of an aerobic. So whatever the process, it can be used for developing a particular product. So the process flow diagram is said to be a diagram which is commonly used in your any chemical and a process engineering to indicate the flow of a plant process and the equipments. So which means that it contains a bulk of a chemical engineering data for designing of a chemical process for any product development. So here, this process flow diagram which displays the relationship between the equipment facility of your plant with your details and your designations. So that is how we are going to make a loop arrangements or a wall arrangements, everything that has to be taken care in the case of a process flow diagram. So it displays the relationship between the equipment of a plant facility. So this is a simplified diagram that can be explained in the case of a process flow diagram. So we all know that the bioprocess flow diagram, which means that it can has a 3 steps. The one is the upstream. The second one is a fermentation. That is the heart. This is said to be the heart of your fermentation process. And then the downstream. So when you talk about the upstream, so this is the flow sheet. So from we are going to prepare the media, and this has been taken to the fermenter for your fermentation process. So the next one, once a process has been formed and how this process is being, product is being separated out, and how it is purified, and how what are the finishing stage we are going to give, and how we are going to marketing those products, like filling, on how which way, on how we are going to do the marketing process. So this process flow diagrams, which includes a rich set of symbols. So here when you talk about a symbol, so listen here. So when you talk about a symbol, this represents in the case of a fermenter, which represents your agitator or an impeller. This is for a proper mixing of all the reactants we do have. And then when we talk about your next one, how this filter is being carried out. So the filtration with symbol which will be taken in the case of your denoted as this one. And how, so what is the next step? So like this, we have n number of unit process steps that has been covered in the case of your process flow diagram. So it is said to be a simplified diagram which describes your input to the output, what are the steps that has been taken for a product development, and it also has a set of symbols that covers all the elements which has been needed for your process of engineering. So here it indicates what are the various symbols that has been used for your things. Whatever the parts of a fermented we do have, those can be represented in a simple form. The first one, agitator, that can be represented as your this way. This way, the agitator. This is a symbol. And for filter, it will be shaded like this. And like that, we have a n number of symbols for a various numbers of a unit operation equipment. That is has been denoted as each and everything. So for your these things, agitators, your apparatus elements, centrifuge, compressors, and your grinders, your drivers, your engines, feeders, fillers, aerators, spargers, baffles, everything that has to be considered for a flow sensors, and how the heat exchangers, your instruments, mixers, the pipings, walls, whether the wall is closed or open, and those can be represented in a simple form that gives you the detailed information about the process flow diagram for any product formations. Okay, so this is said to be your simple flow diagram that depicts your any chemical process. So here, listen here. So here when you talk about, this is said to be the reactor. Okay, so this is of our reactor. We are going to make the gas from the bottom of your tray. Okay, so here there will be a sparger here, and this will be taken once the reaction is being carried out. This is taken to the outlet. So this symbol represents your outlet of your thing. And when we are having this thing that will be taken to the next level for a recycling of our product, this is said to be the condenser. And this is said to be your junctions where your this outlet is taken or acting as a source for your next chemical unit operations equipment. Okay, so here in this case, it will be taken to the next level for removing this gas as an output. It is being pumped with the help of your pumps. So the pump symbol can be represented as like this. So each and every unit operations what we do have, that can be represented in the symbol like this one. If it is of a condenser, this condenser will be with the help of your this thing that can be denoted. And this is said to be the pumps. Okay, so here once it has been done, these are the things that has been taken into consideration for depicting your chemical engineering unit processes, which includes each and every steps of a unit process. So if it is of an agitator, it will have a symbol like this. If it is of a condenser, it will be like this. If it is of a junction that connects between the one unit and the other unit, like this one. If it is of a pump, it will be denoted by like this. And if it is of an output, how it has been carried out. So the example we will see the air dryer and a filter system. So when you talk about an air dryer and a filter system, how we are going to give an air and how we are going to dry the air and how we are going to filter the air for a process into the product for a fermentation process. So here the instrument air is made available to the airhead by compressing the atmospheric air, and it is needed to be dry at some extent so that it will not become with the help of your moisture. So here how we are going to if we are giving a moisture of your air which impacts your disease, so that has to be sterilized with the help of a air dryer and the filter system. So this can be done with the help of this. So this is the thing that helps for detailed description how the air is being filtered and making it to be a sterilized for any fermentation process. So here in this case, we'll be making the air from the compressors to be let in, and this will be sterilized in the case of your drying. So once it has been sterilized and regenerated, it will be taken to the next filters for your next processes. So this will be acting as an output so that it will be taken to the fermenter for any reactions to be carried out. So here in this case, see the symbol here, and this is said to be the filter. Okay, so this is how the filter where you are going to filter the air, and this is a heater from your compressor or a fan or a blower, the heater is being, and this air is taken to the filter for a heating purposes. Then it is being taken to the filter system for any process. Then it is for a filter, and air is for a regeneration process, and this filtered air can be used for any product development. So the next example we'll see about the distillation unit. So when we talk about the distillation unit, and this is said to be the feed we are going to give, and this feed we are going to give to the reactor through the feed tank. And to this reactor, it will be having your high pressure separator. Then it will be taken to the next stripper, and that can be represented as this symbol for your desulfurized product for your distillation process. So the next one, we'll see about the equipment design and the specification. So when we talk about the detailed design and an equipment specification, it involves a specification of an equipment that has been used in each and every steps, like your vessel or your exchangers or a pumps or any instruments that has to be determined, that has to be detailed design that has to be given with the equipment selection. So here, whatever the project is being there, and here it comes there, if there is a change, will be a change in the design, and that will be giving you the optimized process for your product formation. So that can be done with the help of a flow sheet diagram. So here it gives a this can be done only when we are designing a detailed design, that by collecting the data from your preliminary design, and when we need some changes for a product optimization for a product formation in a larger quantity, that can be done in a better idea that has to be developed. And the case of changes, that has to be done only on a flow sheet diagram and not on a while the process is being carried out. So the goal of any engineer, either it might be unit engineer, unit process engineer, bioprocess engineer, chemical engineer, is to design the engine, is to make the process or whatever the things that we need, that has to be done at all the cost. So if the design of engineer is needed to decide whether what type of things we are going to use for a distillation column or any unit operations. So the goal of a bioprocess engineer. So as a bioprocess engineer, how we have to be? So we need to, for any product or a plant design, we need to develop a complete biochemical process in an effective manner for a product formation in a larger quantity. So those steps that has to be explained in such a way with the help of a process in a successful manner for 100% product. And how we are going to design the equipment also we have to be taken into a consideration. So the engineer, so the goal of an engineer is to develop a complete biochemical process in an effective manner, that for by preparing a specification for individual equipments in each and every steps that has been included. So it's from starting from the collection of the materials, starting from the input, how the valving is being done, loops, everything, your inlets, your media optimization, everything that has to be done, taken into consideration for any product development. So that is the main goal of any engineer who's been developing a complete process in an effective manner for a product formation. So this is said to be your what are the requirements that has been needed, and what are the specification, technical specification, those things that has to be comprised in the case of a qualification plan. And then once a plan has been done completely, we'll be finally reporting as a making that report as a design qualification data. So this how this qualification plan and a report can be done. Here this can be done with the help of a process design and those specific equipment specifications of an equipment. So here how we are going to process designing. So how the design that has been done, whether it is of a conceptual or preliminary or detailed or a rough estimation or a process designing, that can be determined. So from the front end to the end of a product. So here when we are once the designing has been done, how we are going to commissioning the plant. So like your plant preparation, plot preparation, site specification, plan startup, everything that come into a. So here it considered to be the operation of a plant and what are the equipment that has been needed for your plant. Those can be considered in the case of a process design and a process specification of your major equipments. Okay, so this it can be implicated in all the large scale industries, like either it might be oil industry or chemical industry, gas, petroleum, engineering, bioprocess, pharma, any industries if you take, that should be of a designing of a process through the process flow diagram, and also needed for an equipment specification that is needed for any product development. So how we can scale up? The next one is see how we can scale up the equipment designing. So if we are having an accurate data, so when we needed the scale up, so the data that we have been collected from through the feasibility survey, if those things, the data are insufficient or inadequate, we have to make an adequate information to design a process for a large pilot scale industries to produce a product in a larger quantity. So which means that if when the scaling up of equipment has been done, if your accurate data are not in the literature survey, or if the adequate information is not being provided in a pilot plan for designing an effective plan, we can be shifted into the large pilot scale. Then it can be needed up for a scaling up of a designing in an equipment. So equipment, which means what are the various equipments we do use in the case of a bioprocess or unit process or your any things, that equipments, it includes all the equipments like your heat exchangers, dryers, columns, pumps, valves, safety factors, how the data is being designed, everything that has to be taken into the consideration. So that is why the scaling up is needed when data are inadequate. In the case of a lab scale, then it has to be taken into consideration into the lab scale. What are the safety factors? So here when we talk about the safety factor which means that it represents the amount of a design operating performance with respect to the time, the increase in the capacity requirement, and they should be more, and this decision has been based on the existing condition. So already if there is an existing condition, then we have to take in that as a preliminary one for designing a safety factors for the labors, technical or a non-technical categories. So here when we talk about equipment specification, it's mainly based on a material construction. So when we talk about a material construction, so if it is of a fermenter, the material should be made for a lab scale, it can be a glass. But in the large scale of industries, we cannot make use of your glass material as a construction material for the equipment. So it has to be done in such a way in a stainless steel. So those stainless steel should not be of a robust, and then it should be a mixture of all the things that has to be done for a preparation of a fermenter as a type. So those things, whatever we do need for a construction of a media, that's a specification for the particular equipment has to be quoted or has to be make a note to the vendors or a manufacturer, so that they prepare based on whatever we are given as specification. They will prepare your equipments for our process development. Okay, so here they will be providing your lower price quota code for a better guarantee, and so that it gives you, so we must be very carefully done, it has to be done very carefully, since the equipment should be standardized than the special equipment. Okay, so this equipment should not be of robust, or should not, if a fermenter if we are using, the fermenter should not be a robust, or it should not be of a breakable one. It should be of a standard equipment that we'll be using for that product to be produced for n number of times in a large scale industries. So rather than the special equipment, we have to be stick on to the standard equipment. So that's why the engineer, that's the goal of an engineer. That's why we say the goal of an engineer is to design and evaluate the needed by preparing from the preliminary specifications. So the next one is how these preliminary specifications can be denoted. So whatever the materials we have been constructed for the equipment, those specification has to be mentioned on a fermenter or any equipment. So that is how it can be done. So the first one is an identification. function, operation, materials handled, basic design, essential control, insulation requirement, tolerances, and what are the various miscellaneous that has been needed. So based on the first one, it's an identification. So I'll give you an example for your tray column. So how this column has been done. So what are the identification this mean? So identification in the sense, what are the item number, how many unit of a column, C tray column has been used, and what is the item number and how many items it has been needed, when it has been manufactured, and when it has been installed by the industries. And the second step is your function. So how this C tray column is being functioned, or how it can be operated, and how we are going to handle those materials based on the quantity or a composition and a temperature, and how we are going to design the data in the case. So like your how many trays, since it is of a tray column, and how many trays we are going to use, what is the size of the sieve and the whole size and the arrangements, what is the tray thickness, how it can be occupied, and what is the diameter of those tray column, everything that has to be taken into the design data. Then it will be having your utilities, controls, insulation, tolerances, and the comments in the drawing. Tolerances in the sense, what are the various miscellaneous that has been needed for your any sieve tray distillation column. And the second equipment, let us take a see with the second equipment, that is a heat exchanger. So when you talk about a heat exchanger, what type of an identification we can do? So this is the basic identification of any equipment we are going to specify while designing. So here we see with the help of a heat exchanger what item it is. It is a condenser item. It provides the heat for any product. So how many item is being needed, or how many number is being needed, that can be. So how many it is being in, when it has been installed, and by whom, that is the company name. So here in this case, when the next to the identification, it's a function. So what is the function of it? So it contains your vapor from whatever the water we are going to give, that has been converted into the heat air, so that the process being carried out for a fermented. So the heat air is being passed, so it is being sterilized, so it is being taken into the further process to carry on. So how it is operated, whether this operation is being done in a batch or continuous, or a fed batch, or a semi-continuous mode. So that has to be taken into account. The next, what is the type of this heat exchanger? Whether it is a horizontal column or a vertical column, those things that has to be specified. So the next one, what are the tube size? So specification of your this thing. So what is the tube size, and whether this tube size is a straight or a curve type of a things, or whether it can handle also the cooling water or your cooling heat air, everything. So if we are giving a cooling water, it will convert that into the hot water for the process. So what is the material that has been made up of, and what is the cell size, and how temperature and pressure is being taken out for a heat exchanging for heating the air or of water. So what are the other utilities? So we can treat untreated cooling water also for converting them into condenser, converting with vapor is condensed into the hot water. So the next one, what are the controls? It can be controlled with the help of a temperature sensor in the vent line. So what is the flow line of a water that can be done? Then how it has been insulated, your tolerance level, as per your standard, it has to be fixed. So what is the diagram? So the location and size of a diagram that has to be done on a basic flow sheets that has been specified on a reactor itself. That is on a unit process of a heat exchanger itself. So here, when you talk about the precautionary steps, so what are the various precautionary steps should be done? We have to taken care by avoiding unnecessary restriction. So which means that whatever the things that has not been needed, that we have to restrict ourselves. So the final design, if there is a final design to be done, that can be changes can be done in the preliminary design. So which will be reducing your first cost, but not in the effectiveness of an equipment. Okay, so here the next one, your labor charges also to be eliminated. So what do you mean by the labor charge? So each and everything that can be monitored in the case of a monitor itself, rather than employing the labor, which needs a labor intensive technique. Rather than that, the labor charge can be rendered if it is of a monitored sensor. So that is a digital form or a distance. So then it can be used to avoid your unnecessary restrictions. So what do you mean by the unnecessary restrictions? In the sense, here, whatever the things which is not be needed, if you are bypassing the product, that product should not, if you are bypassing the byproduct, it should not involve in a product formation interference. So that has to be taken care by avoiding your unnecessary restrictions.